we've been working with the standard form of a quadratic equation. So we have ax squared plus bx plus c equals 0. In the factored form, we would have factored out the a, and then factored the x squared plus whatever a divided by, or b divided by a is and c divided by a is. And that gives us a times x minus p times x minus q equals 0. So for our example, here's our standard form where a is 1. So we don't really need to factor that out. But if we factor this trinomial, it's going to give us x squared, or x minus 6 times x minus 2. So this would be our factored form. And it's p and q are the roots, which are the solutions. So our roots are 6 and 2, because it's minus the root. So if you have a negative here, your root is positive. If you have a positive here, your root will be negative. Which means that this graph is going to cross the x-axis at those 2 points. 2 and 6. And if I were to finish graphing it, I'm going to get -4. So our graph would look like that. So factoring the quadratic equation is another way to find the roots. That means you don't have to graph it. Questions on that? By going from roots to an equation. So what I have is a times x minus p times x minus q equals 0. I've not been given an a. So I'm going to go ahead and take that out for right now. Which will leave me with just x minus p times x minus q. And I've been given roots, so I'm just going to name them p and q. It doesn't matter which is which. I'm going to plug those in for p and q here. So it's x minus -1/3 times x minus 6 equals 0. So that's x plus 1/3 times x minus 6 equals 0. And you guys remember our good friend FOIL? So it's first, outside, inside, and then last. So I'm going to multiply the first. That'll give me x squared. Outside. So minus 6x. Inside. So plus 1/3 x. And then last. 1/3 of 6 is 2, so that's minus 2 equals 0. And then I need to combine my like terms, but you guys don't like working with fractions, right? So why don't we get rid of the fraction? My denominator is 3, so I'm going to multiply this whole equation by 3. Which will give me 3x squared minus 18x plus x, because 3 times 1/3 is just 1, minus 6 equals 0. Now I can combine my like terms. Okay, so now I have standard form. Ax squared plus bx plus c. Okay, again, we're not given an a, so all we need is x minus p times x minus q equals 0. Call these p and q. So I have x minus 3/4 times x plus 5. So that's your minus -5 gives me plus 5. I'll FOIL it. So first is going to give me x squared outside plus 5x. Inside minus 3/4 x, and then last is going to give me negative 15/4. Right, because I multiply the 3 times the 5, and then the 4 stays your denominator. Okay, and we don't like working with fractions, so we'll get rid of them. Our denominator is 4, so we multiply the whole thing by 4. So I get 4x squared plus 20x minus 3x minus 15 equals 0. And then because the 4 out here, this 4 cancels my denominators. And then combine my like terms. Okay, so in general, if you're talking about the greatest common factor, and I have some variables and numbers, whatever, I look at, okay, I have 3 A's in the first term, and I have 1 A in the second term, so I can only take out 1 A. Because I can only take out whatever my least amount of them are. I have 2 B's and 2 B's, so I can take out 2 B's. I don't have any n's in the first term, so I can't take any n's out of either term. Well, if I took 1 A from the first term, I have 2 A's left. If I took 2 B's from the first term, I have no B's left. I didn't take an n out. I took the A away, and I took both B's away. And that's just all kinds of confusing. But when we FOIL things, for example, if we were to FOIL this, we'd get A times C x squared. That's how we get this. You get AX times D, so that would be ADX. So that's where this AB comes from. And you get B times CX, so that's where this BC comes from. And then you multiply B times D. So basically, we undo FOIL, which we will talk about more in a general sense in a moment. Difference of squares is probably one of the easiest things to factor ever. If I have a perfect square minus a perfect square, take the square root of the first plus the square root of the second times the square root of the first minus the square root of the second. And then if I have perfect square trinomial. And then you also have the negative. So the first and last term are perfect squares, and the middle term is when you take the two square roots and multiply them by 2. So we'll go over that too. These are also fairly simple. Difference of squares is probably the easiest, followed by greatest common factor, followed by perfect square trinomials, and then general trinomials can be a little bit rough. But we'll go over a few different techniques for that. So let's look at the greatest common factor. First we check out the numbers. I have a 16 and an 8. What will both of these divide by? 8. Right? Because 8 goes into both 16 and 8. And then I look at my variables. I have 2 x's in the first term, 1 x in the second term, so I can only take out 1 x. And then I look at what's left behind. If I divided 16 by 8, that leaves me with 2. And I had 2 x's, I took 1 away, so that leaves me with 1 x. If I divide 8 by 8, that gives me a 1. There was 1 x, I took it away, so I'm done. Good, bad, indifferent? Let's try another one. What will both 20 and 15 divide by? 5, thank you. Okay. I have 2 x's in the first term, 1 x in the second term. So I can take out a maximum of 1. I have 1 y and 2 y's, so I can take out 1 y. Okay. When I divide 20 by 5, I get 4. I had 1 x, or I'm sorry, I had 2 x's, I took 1 away, so I have 1 left. I had 1 y, I took it away, it's gone. 15 divided by 5 is 3. I had 1 x, I took it away, so I have no x's left. I had 2 y's, I took 1 away, so I'm left with a y. Better? All right, 25 and 45 will also both divide by 5. 1x, 2 x's, so I can take out 1. 2 y's and 2 y's, so I can take out 2. I have a z here, but I have no z's in the second term, so I can't take out any z's. 25 divided by 5 is 5. I took away the 1x, I took away the 2 y's, so I have left is a z. And then 45 divided by 5 is 9. I took away one of the x's, so there's an x left, and I took away both of the y's. And by take away, I said technically speaking, I factored them out. Grouping, personally, a lot of people don't, but when you have 4 terms and you want to factor it, we can factor trinomials. We can factor binomials. We cannot factor a 4-term just as it is. We have to factor by grouping. So what we do is our first step is we're going to rearrange so that the terms that have common factors are next to each other. So if I look at this, I have 7x squared, I have 6xy squared, I have 14xy, and I have 12y to the third. 7 and 6 don't really have anything in common. But 7 and 14 do. So I'm going to put those two together. So I'm going to put 7x squared plus 14xy. And then 6 and 12 also have something in common. So 6xy squared plus 12y to the third. So now I've put numbers together that have common factors. So then what I'm going to do is I'm going to factor that common factor out. Okay. 7 and 14 have a 7 in common. And then I have 2 x's and 1 x, so I can take out 1 x. And I'll be left with 1 x, and then 14 divided by 7 is 2, and I'm left with a y. And then when I come to my next two terms, I can take out a 6. There's only 1 x in the first term and no x's in the second term, so I can't take out any x's, but I can take out 2 y's. And if I do that, I'm left with an x. 12 divided by 6 is 2, and there's 1 y left. And this is where the magic happens. These match. Beautiful thing, isn't it? So, okay, so I have these matching parentheses. That's one of my factors. Essentially what I'm doing is I'm factoring out that matching parenthesis. But so I just take what's in the parenthesis and I write it down once. And then what goes in the second parenthesis is the stuff I factored out. So 7x plus 6y squared. So matching becomes one, and then the terms outside become a second. Questions? All right, we've got the second and the last term both have C and D in them. So those should go together, and then the first and the third term only have A's and B's, so those should go together. So and I can factor out what from the first two terms?
First two, A and B.
1A and 1B. If I factor an A and a B out of AB,
It's nothing.
it's not nothing exactly, it's 1. Because there's an invisible 1 there, so if I take the A and B away, I'm just left with the invisible 1. And then I have a 4 and an A. And I can factor out of the second two terms. Anyone?
Oh, C and D.
And a
2.
2, yeah. And if I factor 2 C and D away from the first one of those, I'm left with 1. And then
Confusion.
6a. What did I do wrong? Hold on. This was a typo. This 2 should be a 3. So we'll just change it to a 3 here, change that to a 3. And then, that's really hard to see, sorry. Darn my typos. Although that was cool though, because it's teaching you a valuable lesson. If you write the problem down wrong, then you don't match. And if you don't match, then you've done something wrong. So then you can go back and check and see what you did wrong. And in my case, what I did is I essentially wrote the problem down wrong. So this is a good thing. And now I have matching again. So 1 plus 4a becomes my first parentheses, and then my second parentheses is ab plus 3cb. All right, so perfect square. If I have a plus b squared, what that equals is a plus b times a plus b. And if I FOIL that out, I get a squared plus ab plus ab plus b squared. And so what it really equals is, oops, a squared plus 2 times a times b plus b squared. And it's the same thing if I have a minus b squared. The only difference is instead of plus 2ab, it's minus 2ab. So when you have a trinomial, the first thing you'll check is, does it have a greatest common factor? It does not. Then the second thing you'll check is to see if it is a perfect square trinomial. So we look at the first and the last term, and we check to see if these are perfect squares. Okay, the square root of x squared equals x. And the square root of 64 equals 8. Okay, so those are both perfect squares. Then we take these two squares and I multiply them together times 2. So 2 times x times 8 is 16x. If this term right here matches this term right there, you have a perfect square trinomial. And then you take the two things that you multiplied together and square them. Don't worry, we'll do another one. X and 25 are perfect squares. Yes, we agree? Square root of x squared is x. Square root of 25 is 5. So far, yes, we agree? If I take 2 and I multiply it by x and I multiply it by 5, I get 10x. Which matches, which means this is a perfect square trinomial. So then to factor this, do x plus 5 squared. So the square root of the first term plus the square root of the last term, and then square it. So when we have a negative, it's the same process pretty much. I'm going to take the square root of 4x squared. Well, the square root of 4 is 2. Square root of x squared is x. And I'm going to take the square root of 9, and that's 3. And I'm going to multiply 2 times 2x times 3. 2 times 2 is 4, times 3 is 12, so I get 12x. This matches that. So it is a perfect square trinomial. The difference between this one and the last ones, though, everything was positive on the last ones. Here we have a negative. So instead of being 2x plus 3, make it 2x minus 3. So whatever sign the center term is. So if the center term is plus, then your square will be plus. If the center term is minus, then your square will be minus. Do you guys need to see another one? Let's do. Yeah. So square root of 16x squared is going to be 4x. Square root of 81 is 9. 2 times 4x times 9, that's 8x times 9 is 72x. 72, 72, so it matches. So I get 4x minus 9 squared. And again, it's minus because it's minus 72. The 2 comes from this, because if you were to FOIL those back out, you get 2 of them. So you'd have 2, so that's where the 2 comes from, so it's always 2 times the 2 things.
The actual equation that would be like in that case.
The squares is, if I take 2 terms that are the same, or 2 binomials, but one's a plus and one's a minus, and I multiply those together and I FOIL it all out, I would get a squared minus ab plus ab minus b squared. Well, plus ab and minus ab cancel each other out, and so what it actually ends up being is a squared minus b squared. So when you have a difference of squares, we take the square root of the first term. So anytime you have a binomial like this, again, the first thing you want to do is see, are there any common factors you can factor out? No. Well, I guess I can factor out a 2. Or 4. I can factor the 4. But I don't want to do that. And the reason I don't want to do that is because these are perfect squares. If they're not perfect squares, then go ahead and factor something out. But because these are perfect squares, if I factor something out, I'm actually going to mess it up. So you have perfect squares already, you're not going to factor out a GCF. If they're not perfect squares, then go ahead and factor out the GCF. But these are already perfect squares. 36 is perfect, 64 is perfect. So what we want to do is we're going to take the square root of each. So I'm going to take the square root of 36a squared. So square root of 36 is 6a. And then I'm going to take the square root of 64y to the 4th. Now I know that y to the 4th is perfect because it's an even exponent. All even exponents are perfect squares because they'll all divide by 2. So I take the square root of 64, which is 8, And then I say 4 divided by 2, so that leaves me with y squared. So if it was 6, it would be y to the third. When you take the square root of it, if it was 8, it would be y to the fourth. Does that make sense? Now I have my 2 square roots. So the factored form, I take the first and add the second. I take the first and I subtract the second. So anytime you have a perfect square, that's a difference of squares, square root of each term, and then it'll be plus minus. Square root of 81x squared is 9x. Square root of y to the 6th is y to the third. Because 6 divided by 2 is 3. So this factors into 9x plus y to the third, 9x minus y to the third. Nice. And here I was talking about where I don't have perfect squares. But I do have common factor. 27 and 75 will both divide by 3. And I have a y in each term, so I can take the y out. And then what I'm left with, 75 divided by 3 is 25, x squared. 27 divided by 3 is 9. Now I've taken that out, I now have a difference of squares with the square root of 25x squared being 5x and the square root of 9 being 3. So the final factored form, that 3y that I factored out, that doesn't go away. I just carry it over. And then I have 5x plus 3, 5x minus 3. First thing you do is you make a big giant X.
Good.
And then you put a plus
Oh, it's this one. This is too easy.
and a multiplication. And then I take my middle term and that goes with my plus. And I take my last term and that goes with my multiplication. And then I am going to look for two numbers that when I multiply them, I get 20, and when I add them, I get 9. 4 and 5. Whatever numbers you get, that's what goes in your parentheses. It's the big giant X. But you may not like the big giant X. And if you don't like the big giant X, that's okay too. So what I'm going to look for I'm going to write down all my factors of 20. Well, first of all, I have 1 and 20. They give me a sum of 21. 21 does not match the middle, so I won't use it. 2 and 10 give me a sum of 12. Again, doesn't match. 4 and 5, I finally get my 9. So then I'll use these two factors because my 9 matches and I get the same thing. Looking for two numbers. When I multiply them, I will get 30, and when I add them, I will get negative 11. Okay, let me give you a hint. If I have a positive product and a negative sum, that means my two factors are both going to be negative. 6 and 5. So I have negative 6 and negative 5, right? Because negative 6 times negative 5 gives me positive 30, but negative 6 plus negative 5 gives me negative 11. So I have x minus 6 times x minus 5. Okay, table or big giant X? Table? Okay, factors of negative 21. One will be positive and one will be negative because they'll, to multiply to make a negative. So I have 1 and 21. If I make the 1 negative, that gives me a sum of 20. If I make the 21 negative, that gives me a sum of negative 20. That's not what I'm looking for. I have 7 and 3. If I make the 7 negative, I get negative 4. Negative 4 is what I wanted. So this would be x minus 7 times x plus 3. And basically with this, if you have a negative third term, you're looking for factors that will have a difference of the middle term, and then one of them will be positive and one of them will be negative. Looking at this sign will tell you like which the larger number should be. If this is positive, then the larger factor should be positive. If this is negative, then the larger factor should be negative. Right? So we wanted negative, so 7 negative. This doesn't exactly work. We can make it work, but we have to do something first. Because I have a leading coefficient, I need to deal with that. So the first thing I'm going to do is I'm going to take my leading coefficient and my final term and I'm going to multiply those together. Okay. And then I'm going to look for factors of 120. That will give me a 23. So I have to find factors of 120. Now the big giant X, if this is a small number that you can think of all the factors of pretty easily, the big giant X would still work here. But 120 is not necessarily the easiest thing to think of the factors of. So I'm going to make a factor table on this one. Okay, so factors of 120, well, the fastest ones that come to my head are 12 and 10. They're going to need to both be negative because my product is positive, but my sum is negative, so that gives me negative 22. Close. Not there yet. I can go, well, 6 and 20, but that won't work because that'll give me 26. I can take a 2 away from the 10 and multiply it by the 12. And that would give me 24 and negative 5. That's negative 29. That's not going to work. I can take 8 away from the 24 and multiply it by the 5. That doesn't work. Could take 5 away from the 40 and multiply it by the 3. Negative 23. So I found my factors that work. Now what I do is, okay, so let me write this down. So first, we multiply leading coefficient and last term. Second, we find factors. with the sum of the second term. Factor by grouping. So in order to factor by grouping, we're going to take the two factors and we're going to replace the second term. Second has to be in it. So what I'm going to do is I'm going to take negative 15 and negative 8 and I'm going to replace the negative 23 with that. So this will become 6y squared minus, okay, I'm going to look at 15 and I'm going to look at 8 and I'm going to see which one do I think has more in common with 6. I'm going to do 8 because they're both even. So minus 8y minus 15y plus 20. Because negative 8 and negative 15 adds up to negative 23, all I've done is split it. And then I'll factor out the common term. So 6y squared and 8y both have a 2 and a y in common, so I'll take out 2y and I'm left with 3y minus 4. And 15 and 20 both have a 5 in common, so I'm just going to take out the 5. Oops. And I get 3y plus 4. Sorry, negative 3y. Because negative 15 divided by 5 is negative 3, and that almost matches, but not quite. So I also need to take out my negative. So I need to make that negative 5. So if I make it negative 5, then the two signs inside will change. And now it matches. Does that make sense? So if your signs are wrong, if it almost matches but your signs are wrong, then change the sign out here. And if you change the signs out here, then you can change the signs inside. Now they match. So that becomes my new factoring. So if you don't like the grouping thing where you multiply the first and the last and find those factors, if you don't like that, there's also what I like to, I guess you'd call it the reverse FOIL. What I'm going to do is I'm going to find factors of 6, and I'm going to find factors of 20, and then my combinations. I'm just going to call them combinations for lack of anything better. Okay. Factors of 6, I have 2 and 3, and I have 1 and 6. Factors of 20, I have 1 and 20, 2 and 10, and 4 and 5. Okay. If I try the first combination, and I do 2 times 1 plus 20, or sorry, 3 times 20, so 2 times 1, 3 times 20, I'm going to get 62. This does not work. So then I'll try it the other way, and I'll do 2 times 20 plus 3 times 1, and that gives me 43. Doesn't work. Guys, shh. Then I try the second combination. So 2 times 2 plus 3 times 10 gives me 34. And then I try 2 times 10 plus 3 times 2 gives me 26. Okay. Then I try the next combination. 2 times 4 plus 3 times 5. That finally gives me 23. Okay. Now that I have the first or the correct combination, if that hadn't worked, I would have tried the next, flipped them, and then if those didn't work, then I would have gone to 1 and 6 and done the same thing over again. Does that make sense? Okay. Now that I have the correct combination, I know that the factors of 20 have to be negative because the center term is negative and 20 is positive. And I know that 2 has to multiply times 4. So I'm going to do 2x and then minus 4. Because they have to be in opposite parentheses to be being multiplied together. And then I do minus 5 and then 3x. All right, so grouping on the first one. I do 15 times 1 is 15. And I'm looking for factors of 15 that will give me an 8. I can use the big giant X for this one. So factors of 15. Well, I have 1 and 15 or 3 and 5. Well, 3 and 5 give me an 8. And they need to be negative because it's a negative 8. So I have 15x squared. And I can use either of these. I'm just going to use the 5. So minus 5x minus 3x plus 1. I can take a 5 and an x out of here. And I'm left with 3x minus 1. And then from my second set, the only thing I can factor out is a 1. But if I factor out a 1, this 3 will stay negative, and I want my 3 to be positive and my 1 to be negative, so I'm going to factor out a negative 1. So I get 5x minus 1 times 3x minus 1. If I use the reverse FOIL method, I know that my first term is negative. Actually, no. Sorry. Scratch that. Well, it'll be about the same. I don't want my first term to be negative. So I'm going to change this, and I'm going to go ahead and factor out a negative 1, which will make this 12x squared minus 8x minus 15. I always want that leading coefficient to be positive when I'm factoring. It just makes it easier. So factors of 12. Factors of 15. And they're negative 15. So I'm going to have a negative 1, positive 15, or a positive 1, negative 15, negative 3, positive 5, or positive 3, negative 5. And I'm trying to get a negative 8. I know this one's probably not going to work already, because if I do 1 times negative 1 plus 12 times 15, that is not 8. And if I switch it and I do 12 times negative 1 plus 1 times 15, also not 8. So I try those. 1 times negative 3 plus 12 times 5 is not 8. 1 times 12 plus Sorry, not 1 times 12. Got my factors mixed up. 1 times 5 plus 12 times negative 3, also 1 times 15. Sorry. That should be 12 times 15. No, I'm in the wrong place again. God, guys. Your sleepiness is wearing off on you. Okay, still not 8. And if I switch the signs, I'm still not going to get 8 from this first set, right? So if I switch and make it negative 15 or negative 5, it's still not going to give me 8. Okay. So I'm going to try the next set. 3 times 3, well, negative 3 plus 4 times 5. That's negative 9 and 20. That gives me 11. That doesn't work. If I do 3 times negative 5 plus 4 times 3, I get negative 15 plus 12. Doesn't work. If I do those, 3 times negative 1 plus 4 times 15, or 4 times negative 1 plus 3 times 15 also won't work. And if I just switch the signs, I still don't think it's going to work. Do you guys like the grouping yet? All right, let's try these. 2 times negative 1 plus 6 times 15. No. How about 2 times 15 plus 6 times negative 1? No. Two times negative 3 plus 6 times 5. 2 times 5 plus 6 times negative 3. Aha! Finally! That'll give me a negative 8. So, my factored form is going to be 2x minus 3 times 6x plus 5. Product property, if I give it to you in technical terms, would be a fancy way of saying if I multiply two numbers and the product is 0, then A equals 0 or B equals 0. One of them has to be 0. You cannot multiply two numbers together and get 0 and then have both of them like be 2 and 3 or something, right? One of them has to be 0. Or they can both be 0. But at least one of them is 0. That's the 0 product property. So what we can do is we can use the 0 product property to solve equations. Like this. Okay? We want to know how long is the javelin in the air. Well, okay, when you throw a javelin, it does like this and it lands, right? Parabola. So, you know, if I throw this, it's eventually going to make a curve and it's coming down to Earth. This formula gives us the equation of the parabola for the javelin. The time is how long it's in the air, and so we want to know how long is it in the air, so we're going to set that equal to 0 because it's no longer in the air when it has landed on the ground. And the height, this is height, would be 0 at that point. So we do negative 16t squared plus 79t plus 5 equals 0. And remember, I don't want my leading coefficient to be negative, so I'm just going to divide it all by negative 1. And then I'm going to factor this. I'm going to use grouping. And I'm going to take 16 times 5, and I'm going to get negative 80. And so I'm going to look for factors of 80 that will give me a 79. Well, it's a negative 80, right? So I could do negative 80 and positive 1, and that gives me negative 79. Right? Do you guys agree? So I'm going to take this $80 and 1 and replace 79 with that. And I'm going to divide both of these by 16 and t. And then I'm going to divide both of these by 1, because there's nothing else there. I have matching parentheses, so what I end up with is negative 1 times 16t plus 1 times t minus 5 equals 0. And I wrote too big. The zero product property tells me that if I have things being multiplied together, at least one of them is 1. Well, negative 1 is not, or sorry, at least one of them is 0. Negative 1 is not 0. Do we agree? We could get rid of that. We can divide both sides by negative 1, it goes away. So I have 16t plus 1 equals 0. And then I have t minus 5 equals 0. So I take each of those parentheses and set them equal to 0. If I subtract 1 from both sides, I get 16t equals negative 1. Dividing by 16, I get t equals negative 1/16. And can I have negative time?
No.
Right? Because we don't have time travel, so we can't go backwards, so we don't have negative time. It's just not that. So t is 5. So javelin was in the air for 5 seconds. We have one more example. Did everybody get this? Factoring if it's not equal to 0. We want to set this equal to 0 first. So I'm going to take this 5 and I'm going to subtract it from both sides. So now it's equal to 0. Now I can solve it. So I'm going to factor, bless you, 12 and negative 5 is going to give me negative 60. And I'm going to look for factors of 60 that will give me a 4. So factors of 60, I have 2 and 30. That won't give me a 4. There's no way. 4 and 15, that won't give me a 4. 12 and 5 will not give me a 4.
10 and 6.
10 and 6, thank you. And I want my 4 to be negative, so I want my 10 to be negative. Thank you. So I have 12x squared, guys, plus 6x minus 10x minus 5. I can take 6x out of both of these, and I get 2x plus 1. And take negative 5 out of both of these. And I get 2x plus 1. They match. And now that I have it factored, I set each of these equal to 0. So add 5, divide by 6, leave it as fraction. Those are your answers. Your homework for tonight, I don't have any packets left.
You should do like that for Monday.
No. Can I see somebody's packet real quick just so I can get page number off of it? Thank you. Okay. Any questions? I know we covered a lot today with the